myself Professor Sharad S. Patil. I will going to teach you the subject Basic Electrical Engineering, and today we will see the topic number 6, unit number 6, called as the polyphase AC circuits and single phase transformer. In this unit number 6, two parts are there. One is having part A, that is called as the polyphase AC circuits, and part B is single phase transformers. Okay, so how the polyphase AC circuits? In polyphase AC circuit, and first we'll see the polyphase system. In polyphase system means what? Already we have studied in unit number 4 that single phase AC fundamentals. In that we have seen that how the single phase voltage is generated. So how that single phase AC voltage is different with this polyphase system. So what is polyphase system? System which have more than one phase is called as the polyphase system. In single phase system we have seen that the voltage is generated in the coil in one phase only. So whenever the system which have the more than one coil, that system is called as the polyphase systems. Then in the polyphase system it always contains two or more than two phases, and they are generated the voltage of the same frequency. So that means we can say the polyphase system is always contain two or more than two phases of same frequency, phases of same frequency. Again, this three-phase power, again in the polyphase system means it may generate the voltage in two phases, three phases, six phases, nine phases, like this. But here in the polyphase system, the three-phase system is the most economical and the efficient, and that's why all over the world this three-phase power is used. As well as all over the world, this three-phase power is generated and transmitted. This three-phase power is first conceived by the scientist Nikola Tesla. This Nikola Tesla have proved that this three-phase system is the only best and the efficient and the economical system in the polyphase systems, and that's why all over the world this three-phase system is generated, transmitted, and used in the polyphase systems. So how this three-phase system? What do you mean by this three-phase systems? So three voltages with a phase difference of 120 degree are available to supply a three-phase load. Such a system is called as the three-phase systems. That means in the three-phase system, the three coils are used to generate the voltages, and these three-phase voltages are readily available to supply the load of three-phase systems. And this is displaced by 120 degree. Whatever voltage is induced in these three phases, all the voltages are displaced by 120 degree to each others. Okay, so why only these three-phase systems are used? That's we will see that what are the advantages of this three-phase system over the single-phase systems. Basically what we have seen that this Nikola Tesla who has proved that only the three-phase system is the best, efficient, and the economical, and that's why throughout the world this three-phase system is used. That's why we will see that what are the advantages of this three-phase system over the single-phase system. We can see in the first advantage, that is more output powers. So of the same size of the motor or the alternator, if you take of three-phase as well as the single-phase, the output power of the three-phase machines is always greater, always more than the single-phase machine, and approximately that output power is 1.5 times than the single-phase powers. Then second advantage, we can see the transmission and distribution economical. As compared to the single phase of the same voltage ampere ratings, if the power has to be transmitted from one point to other point, it will seem that it is economical as well as efficient to transmit and distribute the three-phase power as compared to the single-phase power. That's why whatever copper conductor which is used, which is required for the transmission and distribution of these three-phase systems, it is less as compared to the single-phase systems, and that's why the transmission and distribution is more economical in case of three-phase systems. Third advantages we can see, that is the produced rotating magnetic field, which is not happen in case of the single phase system. In single phase system, rotating magnetic field is not produced, whereas three phase system is produced rotating magnetic field, and which is very important for the induction motors, because induction motor is self-started due to this rotating magnetic fields. Then fourth advantage we can see here for this three-phase system is steady output. So whatever output of this three-phase system is always there, that output is in form of the steady output, whereas it is not possible. That means single phase system is not given any steady output. Then fifth one, we can see single phase supply can be obtained from the three phase supply, but we cannot obtain the three phase supply from the single phase supplies. So this is very important advantage of this three phase systems, and generally which we have seen this in case of the general distribution systems. That is, single phase supply can be obtained from this three phase supply, which is not possible at all in case of the single phase systems. As well as the power factor is good of three phase motor as compared to the single phase motors. So whenever the same rating of the motor of single phase and three phase is used, the power factor of this three phase motor is always good as compared to the single phase motors. That's why these are the advantages of these three phase systems, and that's why all over the world these three phase systems is preferred, is used. Then we'll see that how the generation of three phase voltage will take place. Already we have seen that how the single phase voltage is generated as per Faraday's law of electromagnetic induction. So we have seen that the advantages of three phase system over the single phase systems. The next topic is that generation of three phase voltage. We have seen in the unit number 4 in AC fundamentals that how the single phase voltage is generated when the one armature coil is used as per Faraday's law of electromagnetic induction. The same principle is applied here in three phase voltage generations. Only the difference is that in single phase voltage generations only one armature coil is used. That means only one coil is used, whereas in three phase generations three coils are used, and all these three coils are placed 120 degree apart from each other. The phase shift between these three coils which are placed in the magnetic lines of fluxes are 120 degree to each others. And that's why here you can see in this circuit diagram that how the three phase voltage is generated. So here you will see that R1, R2, Y1, Y2 and B1, B2 are the three coils which are bound on the armature of the alternators, and they are placed in the magnetic lines of flux. And as we know that Faraday's law of electromagnetic induction, whenever the conductor cuts magnetic lines of fluxes, the EMF is induced. So same principle is applied here in the generation of three phase voltages, which was used in case of the single phase voltage generation. Okay, so only the difference is here that instead of the one coil, three coils are used, and all these three coils, they are placed 120 degree each, 110 degree phase shift to each others, and they are rotated at the constant or the same angular speed. That's why whatever voltage is induced in the coil R, Y and B having the same magnitude and the same frequency. This is the reason why the voltage magnitude which is induced in all the coils having the same magnitudes, because here they are rotated, they are moving at the same angular speed. So here we can see this N and S is the either electromagnets or the permanent magnet which produces this magnetic lines of fluxes, and these coils, three coils which are placed here in the magnetic lines of fluxes. So whenever these three coils are rotated at one constant speed, that coils are cut by this magnetic lines of fluxes, and EMF or voltage is induced in these three coils. And whatever voltage is induced in these three coils, having the same magnitude and frequency, but they are displaced to each other by 120 degree phase shifts, because whenever they have placed, they have the 120 degree phase shift among each others. So whatever voltage is induced, that we can represent it with this. So whatever voltage which is induced in these three coils, that we can represent by these waveforms. So you can see in this waveform the voltage which is induced in the coil R, Y and B, which is represented by this waveform. So here you can see this voltage which is induced in the coil R and the voltage which is induced in the coil Y, both having the 120 degree phase shifts. That means voltage is starting to induced in the coil Y after the 120 degree phase shifts of R and Y. Similarly, there is a phase shift between the Y and B of 120 degree. That means the voltage is induced in the coil B after the 120 degree of the coil Y. Similarly, the phase shift between the R and Y, B is nothing but 240 degree. So these are the ER, EY and EB is the voltages induced in the coil R and Y and B, which is having the 120 degree phase shifts among each other. So these voltages we can represent the instantaneous values of these voltages ER, EY and EB. So this ER will be given, the magnitude of this ER at any instant will be given, that is E max sine of omega t. This is the value of voltage in the coil R. Similarly, the value of voltage in the coil Y will be given, that E max sine of omega t minus 120 degree. And this 120 degree is nothing but phase shift between the voltage R and the Y. And similarly, in voltage in the coil B will be given, that is E max sine of omega t minus 240 degree. That means with reference to the R, the voltage in the B will be lagging behind the voltage in R by 240 degree. So this is nothing but the voltages which is induced in the coil R, Y and B, which is represented by these equations, and we have seen here the phase difference between this R, Y and B is 120 degree. So this is nothing but the voltage which is induced in the coils R, Y and B. So here we can see how the voltage is generated in the three phase systems. Again, these voltages can be represented by the phasor diagram. So this phasor diagram which is represented when it is rotated in the anti-clockwise directions. So you will find that there is a phase shifts. So this is nothing but you can see the magnitude of the voltage in the coil R. So if ER is the reference voltage, in such case we can see that ER is the reference voltage, which is given that E max sine of omega t. So EY is lagging behind this ER by 120 degree. Similarly, after the EY, EB will be rotates. That means this EB is lagging behind the EY by 120 degree. Or in other words, we can say this EB, that means the voltage in coil B, is lagging behind the voltage in the coil R by 120 plus 120. That is 240 degree. Or in other words, we can say this voltage in the coil B is leading with the voltage in the coil R by 120 degree. That means in other words, this voltage in the coil B we can write, that is E max sine of omega t plus 120 degree. That means with reference to ER, this voltage in the coil B is also leading with the voltage in the coil R by 120 degree. So this is nothing but the phasor representation of the voltages which is induced in the three coils in the three-phase systems.